Welcome back to the video for secant, tangents, and angle measures example problems. All right, we're going to find each measure, and if we have segments that appear to be tangent, we are going to assume they are tangent. So let's look at number 1. We want to find arc WX, and we want to find the measure of angle Z. All right, so first of all, we have a tangent here that goes out this way. We also have a secant that goes through our circle twice, and so we've got these 3 intersections. So we're going to have 3 arcs on here. One of them is 80 degrees. One of them is 160 degrees. And then we have the rest of the circle. Okay, to find arc WX, we are basically going to take 360 and subtract the 80 degree arc and the 160 degree arc, which comes out to 120. So our arc WX is 120 degrees. Now to find angle Z, we notice where the vertex is first, and it is outside the circle. So that means we're going to use the formula that the angle is equal to half the difference of the arcs. All right, so we have our angle. We'll call it X. X is equal to half of the big arc. And the way we find our arcs is we're going to follow the angle till it intersects the circle. And here it intersects twice. So we have this arc and this arc. And we do the big arc minus the small arc. So we're going to take 160 and subtract 80. So we get 1/2 of 80, which is 40 degrees. So the measure of angle Z is 40 degrees. All right, for this next one, we want to find the measure of angle FJE. All right, so I know I want to find this angle here. We're also going to find the measure of angle FJG, so another angle. And we want to find the measure of arc GH. So this arc right here, we're going to find. I can see right away that angle FJE is a vertical angle to this 45 degree angle. So I know right away that this is 45 degrees. All right, FJG is supplementary. So 180 minus 45 is 135 degrees. All right, now let's find our arc. So we have one arc, we need the other arc. Okay, so our vertex of our angles is in the circle. Okay, so inside. So that means our angle is equal to half of the sum of the 2 arcs. So our angle is 45 degrees, and it is going to equal to half of the sum of the 2 arcs. And so one of them is a 28 degree arc, and the other one, I don't know what it is, so we'll call it X. And then we solve for the equation. Okay, so when I get rid of my fraction here, I'm going to multiply both sides of my equation by 2, and that will cancel out the fraction. So here, now I have 90 is equal to X plus 28, or 28 plus X. Subtract the 28 from both sides of the equation. And we end up with 62 is equal to X. So that arc is a 62 degree arc. Okay, for our next example, we want to find the minor arc and the major arc. So one of the tips is to think of your minor arc as the X value, okay? And then the rest of our circle is the major arc, and that'd be 360 minus X. Okay, so we have our angle. It is outside of the circle. angle M, so it's outside. And so that means we're going to use the formula, the angle is equal to half the difference of our two arcs. All right, so we have our angle, which is 50 degrees, and it equals half of the major arc minus this minor arc. And now we just have to solve the equation. And x is our minor arc, so we'll put that here. And the rest of the arc is 360 minus 130, so we get 230. Okay, the next one. Our vertex, QRS, is on the circle. Okay, and this is what we want to find. So we know that our angle is on the circle, so it's angle equals half of intercepted arc. So the first thing we need to do is find our arc QS. And so we know that the whole circle makes 360, so we have 360 minus 120 minus 140, we get 100. So this arc is 100 degrees. And now we do our angle is equal to half of 100, or x equals, our angle is 50. So the measure of angle QRS is 50 degrees. Okay, next one. We want to find the measure of angle R. So we see right away that our vertex is outside of the circle. So we have the angle is equal to half the difference of our arcs. And the arcs are always the ones in between the rays of the angle. So here's one arc, and here's the other arc. So the measure of angle R is equal to half of 80 minus 40. 80 minus 40 is 40. And so the measure of angle R is 20 degrees. Okay, the next one, X. This angle is inside our circle, so the angle is equal to half of the sum of the two arcs. And so what happens is our angle and the vertical angle, which are equal, both have intercepted arcs, so we're going to use those. All right, so X is equal to half of 52 plus 40. So 52 plus 40 is 92. And so X is 46. So the measure of angle X is 46 degrees. All right, now looking at our next one. We want to find the measure of angle V. Okay, its vertex is outside of the circle. So the formula is the angle is equal to half the difference of the two arcs. So it's going to be this arc and this arc. I know this one's 100, and I have the other two arcs, but I need to know what this one is. So the first thing I need to do is calculate that. And so we have 360 minus 110 minus 100 minus 80. That comes out to 70. All right, now we plug into the formula. The measure of angle V is equal to half of our big arc minus the small arc. 100 minus 70 is 30 times 1/2. So the measure of angle V is 15 degrees. Okay, next one we have our angle okay? And it's inside the circle. So the angle is equal to half the sum of the two arcs. So actually I want x, but if I find this angle, since I already know these arcs over here, I can find that angle and I can subtract that from 180 and I'll be left with my angle that I want. So let's find that one. So we have our angle is half of 130 plus 90, because it's inside, we're going to use the sum. So we have that is equal to half of 220. Okay, so this angle is 110. So we take 180 and subtract 110 to find our x value. And that's 70 degrees. So the measure of angle x is 70 degrees. Okay, for our last one, this is vertex is on the circle. And we want to find the measure of arc TR, and we want to find the measure of arc TSR. Okay, so this angle is 98 degrees, and so it is going to be, remember, if it's on the circle, the angle is equal to half of the arc. So we have 98, and it's equal to half of TSR. So if I multiply both sides by 2, I get 196 equals the measure of arc TSR. Okay, and now I know this angle over here, the smaller angle, is supplementary to 98. So I got 82 here. 180 minus 98 is 82. And so here my angle is half of the arc. So 82 is half of the arc, TR. And so when I multiply that by 2, I get 164. And those are the examples.